the domain and range both are the set of real numbers or any subset of real number, we call it as a real function. All the elements are in relation and every element will have some image in the set of natural number because there are infinitely many natural number. The maximum value of x whatever you take or the minimum value of x whatever you take, so even though if it is negative, it makes the function positive. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Today in this session, we are going to study about the functions and algebra of functions. That is, how we are going to learn functions in terms of relations and Cartesian product and how to add, subtract, multiply or divide whenever two or more functions are given. So let's see, what do you mean by functions? A relation from set A to set B is said to be a function if every element of set A has one and only image in set B. Suppose I take an element from set A as A, B, C and I take set B as 1, 2, 3. So all the elements in the set A has to be in a relation with one element in the set B and it should have only one image. That is, you can clearly see A, 1, B, 1 and C, 3. A has only one image 1, B has only one image 1 and C has only one image 3. So that means all the elements in set A are in relation with some other element in B and that should be one and only one image. I'll take one more example. I'll take the same example A, B, C and here I'll take the set as 1, 2, 3. So when I relate all the elements in set A in this form, that is A is related to 1, A is related to 2, B is related to 2, C is related to 3. When I write this set in roster form, we have A, 1, A, 2, B, 2, C, 3. This is the set we will get. But clearly observe the first two elements here. A has two images here. A has 1 has an image and A also has 2 has an image, which is not a definition of a function. So for a relation to be a function, every element in the first set should have only one image in the second set. But here A has two different images and this is a non-example for a function. Whereas here you can clearly see all the elements in the first set are in relation with only one image in the second set. Hence this is an example for a relation. And let me take the same set A and set B here. So what do you think? Is this is a function? Yes, it is a function because when you write this in a roster form, we have A, 2, B, 2, C, 2. The definition of the function follows that all the element must be in a relation and every element should have only one image. They can also have the same image, but all the elements can have same image, but one element cannot have two different images. So this is the condition. Thus, a function from set A to set B is nothing but a relation where every element of set A has one and only image in the set B. Thus, we have the following important things to note here. A function is a relation such that no two pairs in the relation have the same first element. So here you can see here these two pairs have the same first element. A, 1 also have the first element as A. A, 2 also have the first element of A. So when you are writing a relation, no two pairs should have the same first element. And the other thing is more than one element can have the same image. So here I have given example. We have A, B, C as elements in the first set, they are having the same images. So more than one element can have the same images, but no two pairs cannot have the same images. That is, all the elements should have only one image in set B. So we symbolically write the function in the form as f from A to B and we'll write it f is a function from a to b, and when I write ordered pair belongs to f, we write it in the form of f of a is equal to b. Suppose I write x comma y is an ordered pair which belongs to the function f, then we write f of x is equal to y. So if you substitute the value of x, you will get the image y. This is how we will define, and we call b image under f. So that is, b is called the image under f and a is called the pre-image of b under f. So thus we denote it by the symbol f is a function from a to b. Examine whether the following relation is a function or not. Give reasons. So what are the main things we need to observe? If f is a function from a to b, all the elements should have one and only one image. That means no two ordered pair should have same first element, but many elements can have the same image. So let's look at it now. So we have the relation set 2, 1, 3, 1, 4, 2. So 2 has one image, 3 has one image, 4 has one image. So therefore it is a function. Next question. R is equal to 2, 2, 2, 4, 3, 3, 4, 4. See the first two ordered pairs here. They have the same first element. What does that implies? That implies 2 has two images. One image is 2 and the other image is 4, which cannot happen in a function. This is just a relation, not a function. Next. R is equal to 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7. Look at the first element in each ordered pair here. They are different images. They have different images and hence this is a function. Next. 2, 1, 5, 1, 8, 1, 11, 1, 14, 1, 17, 1. All the first elements have one image, which is 1. That is, many elements can have the same image, but a single element cannot have two images. But the condition this satisfies, many elements can have the same image. So this is a function. Next we have 2, 1, 4, 2, 6, 3, 8, 4, 10, 5, 12, 6, 14, 7. Clearly you observe none of the ordered pairs share the same first element. Thus we can clearly say this is an example for a function. Next question we have 1, 3, 1, 5, 2, 5. So here clearly you see these two pairs have the same first element. That means one has two images, that is 3 and 5. So therefore it is not a function. So this is a non-example for a function, but this can be a relation. And the main thing is to note that all relation cannot become a function, but all functions are relations. Next thing is, here we have real valued functions and real function. What is this real valued functions and real functions? When I say f is a function from a to b, here set A is called as domain. What do you mean by domain in a relation? The set of all first elements inside the relation. We know that every element of A has one image in B. That means all the elements in set A are related to some element in set B. Therefore, the domain elements is all the elements inside set A. That is why we called A as a domain set and B as the codomain set. So this is your codomain set. But range is only the images which are in relation, but it can be equal to codomains also for few cases. Now here, what do you mean by this real valued function means? Here the function which has R or one of its subset as its range. That is, R is nothing but the real number. One of its subsets means it may be natural number, integer, rational, irrational. So if one of the subsets of real number or the real number itself is the range, then we call it as a real valued function. And if the domain and range both are the set of real numbers or any subset of real number, we call it as a real function. Next, let n be the set of all natural numbers and the relation R be defined on n such that R is x, y is equal to 2x, x, y belongs to n. What are the domain, codomain and range of R? Is this relation a function? Now, when I say a function, all the elements in the first set should have some images in the second set. Now here I am defining a relation R from the set of natural number to set of natural number. In a way, x comma y, where y is equal to 2x. So we know that set of natural number 1, 2, 3, 4, etc. It goes on like this. So here we can write 1, 2, 3, 4, 5, etc. It goes on like this. Suppose I write the relation set. If I take x as 1, then y is equal to 2x, 2 into 1, 2. If I take x as 2, 2 2s are 4. If I take x as 3, 3 2s are 6. If I take x as 4, 4 2s are 8. So like this. So 1 to 2, 2 to 4 and 3 to somewhere 6, 4 to somewhere 9. But all the elements are in relation here. So all the elements are in relation and every element will have some image in the set of natural number because there are infinitely many natural number. So therefore R is a function. So we can clearly say it's an infinite set. So therefore R is a function. Now we need to write down the domain. When I say domain, I need to write the set of all first element because here all the elements in the natural number have images in the second set. The complete set is the domain. When I say it is a function, then your first set will be the domain set. So therefore, your domain is the set of all natural number. That means n is your domain. What is your codomain? Again, codomain is the complete second set. So therefore, codomain is also the set of natural number. Now range. What is range? Range is the elements which are in the form of an images, or we can say the set of all second elements. What are the second elements here? 2, 4, 6, 8 and it is infinite. See, clearly you see here the only images are set of all even natural number. So therefore here your range is even natural numbers. Next question. A function f is defined by f of x is equal to 2x minus y. Find the values of f of 0, f of 7, f of minus 3. We have here f of x is equal to 2x minus 5. They have given to find the value at f of 0, next at f of 7, next at f of minus 3. That means we need to take the value of x as 0, 7 and minus 3. So here we get 2 zeros are 0, minus 5 which is minus 5. Here we get 2 sevens are 14, minus 5 which is equal to 9. Here we get 2 3s are minus 6, minus 5 which is equal to minus 11. Next question. The function T which maps temperature in degrees Celsius into temperature into degree Fahrenheit is defined by T of C is equal to 9C by 5 plus 32. Find T of 0, T of 28, T of minus 10 and the value of C whenever T of C is equal to 212. So here C is the variable where we can take 0, 28 and minus 10. Next, we need to find out the value of C whenever T of C is given as 212. So first let us find out what is T of 0. So that means you need to take C as 0. So the 9C by 5 means 9 by 5 into 0. So the value is 32. Next you need to take T of 28. So here we need to multiply C value with 9. So 9 into 28 will get 252 divided by 5 plus 32 which is equal to 50.4 plus 32. We'll get it as 82.4. Next we have T of minus 10. So we'll get it as minus 90 divided by 5 plus 32 which is equal to minus 18 plus 32 is 14 we'll get. Next they have given the value of T of C. That means we need to take T of C as 212 then find the value of C. So we have here 212 is equal to 9C by 5 plus 32. So 212 minus 32 we will get 180 is equal to 9C divided by 5. This implies C is equal to 180 into 5 divided by 9 So you will get the value as 100. So therefore the value of C is 100. Next, find the domain and range of the following function. So f of x is equal to minus modulus x. We know that modulus makes the value of x as positive. So the maximum value of x whatever you take, or the minimum value of x whatever you take, so even though if it is negative, it makes the function positive. If it is 0, the function is 0, and if it is positive, it gives the positive value only. So therefore you take any value of real number. So therefore your domain will be any real number, but range is always positive. But outside we have a negative here. Say for example, if you have minus 3 under the modulus, it makes it positive in such a way that it again takes the negative value and it takes 3. Suppose if you have 0, then the value is 0. Suppose if you have mod 7, then the value is 7. Suppose the value is minus 2 by 7, your value is plus 2 by 7. So whether the number is positive, negative or 0, it always gives 0 for 0 and positive values for both positive and negative real number. Hence, you can take x as real numbers. You can take any values for x. Therefore, the domain is the set of real number. But what about the range here? Range is only the positive here. But here, outside the modulus, you have a negative value. That means even though your modulus function makes the value positive, your answer or your image will be in the form of a negative real number. So therefore, here how we will write the negative real numbers in the form of a interval form, that is minus infinity comma 0. So this is the set of all non-positive real numbers. We can say non-positive real numbers. Next, f of x is equal to root of 9 minus x square. We know that x can take a value which is less than or almost equal to 9. So clearly you can see here x square can take the value less than or equal to 9. Suppose if it is greater than 9, then the root of negative number is not defined in the set of real numbers. We call it as an imaginary number. So this type of number does not exist in the set of real number, or in general we can say nth root of any negative real number does not belongs to the set of real number. So thus we can not take x which will give you the value greater than 9. So what are the possible values we can choose for x here? We can choose the value for x only from minus 3 to plus 3. That is all the real numbers from minus 3 to plus 3, because when you square it, it will not exceed 9. But what is the domain now? So therefore domain, we can say the domain of this function is from minus 3 to plus 3. What about the range? I said under the square root, all number should be positive. There is no chance of getting a negative number inside the square root. So when you square any number, if you take minus 3 whole square is 9, 9 minus 9 is 0. If you take plus 3 square is 9, 9 minus 9 is 0. The minimum value which you will get is 0, and if you take 0 as x, the maximum value you get is square root of 9, which is 3. So therefore, the range of this function is 0, 3. Next function we have, find the range of the following function. F of x is equal to 2 minus 3x. They have given x belongs to real number. That means your domain is real number, but the condition is given x is greater than 0. That means you should take only positive real numbers. X greater than 0 means positive real numbers. So therefore, for the first function 2 minus 3x, the range is from, suppose if you take x is equal to 0, the value you will get is 2 here. If you put x is equal to 0, then f of x is equal to 2. So, but I can't take x is equal to 0, but I can take after x is equal to 0, like 0 0.001, 0 0.005, like that. So that means I have a value 2 whenever x is greater than 0, that is nearest to 2. And all the numbers, if I take x is equal to 1, x is equal to 2, x is equal to 3, if you go on substituting the value here, you will get only the negative real number. Suppose if you take x is equal to 1 here, then it is 2 minus 3 minus 1. And if you go on increasing the value of x, here you will get lesser value in terms of negative number. So therefore, your range always lies from minus infinity until 2. Because you can't take x is equal to 0, you will get the value nearest to 2. Therefore, we will write the interval in the form of minus infinity comma 2. Next, we have here the second one, f of x is equal to x square plus 2. X is a real number. Your domain is a real number. What about the range? We know that x square is always positive. Whether you square a negative number, positive number, it is always positive. And when you add plus 2 to any positive number, it is again a positive number. And if you take x is equal to 0, you will get 2. If you take x is equal to minus 1 or plus 1, you will get 3. So therefore, your range starts from 2 and end until infinity. Why? Because you can take any values for x, you always get a positive number. And the minimum value of f of x is only 2 at x is equal to 0. Therefore, your interval lies from 2 comma infinity. Your range or your image of this function lies from 2 comma infinity. Next, we have f of x is equal to x. X is a real number. Clearly, they have given f of x is equal to x. Whatever x you take, your image will be same. If you take f of 1, it is 1. If you take f of 2, it is 2. If you take f of minus 1, it is minus 1. So, whatever value you take for x, the same value you will get as an image. So, therefore, x belongs to R is the range for the third one. So, your range also lies in the set of real number. Your domain is also real number. Whatever you input inside x, the same element you are getting as an output. So, therefore, your range is also the set of all real numbers. So, thus, this is how we define a function, its domain and range. We'll meet you in the next session with few more concepts. Until then, keep watching, keep learning, keep exploring. Thank you.